Okay, so the goal is to find I of t, and I of t will vary over time, v of t will vary over time, so, well, not, we want to write as a function of time, that's what I mean. And we're given a little bit of information. Okay, so I'm going to start out by asking a question. What type of circuit is this? There's an inductor. Yeah, inductor and resistors, so this is just a RL circuit. And you can find for RL, think about, what do we want to think about? We want to think about IL. So the thing about RL circuits is that the current, right, like the current of this inductor is kind of something that's nicer to think about than the voltage, because when you're talking about currents regarding inductors, their before and after is the same if there's a switch, right? But there's no switch, so you don't really have to think about that hard, but we're just going to think about IL. That's what I'm saying. And IL is, they're calling it just I, right? But we'll call it IL. Okay, nonetheless, let's write out the equation. I of t is equal to I of infinity plus parentheses I of 0 minus I of infinity, and we got e to the negative t, tau. Okay, so let's maybe find tau first. Tau is equal to L over R. And yeah, so we need to find the resistance that this inductor sees. Okay, so let's draw the circuit in this matter. So we have a 5 ohm resistor. We have a 1 ohm resistor. Then we have R here. This is so ugly. Give me a second. R Thevenin here. And so we have a 5 ohm resistor in sight. We have a 1 ohm resistor in sight. And we also have a 20 ohm resistor in sight. And as you can see, there's a node here and there's a node here that both the 5 and the 20 are sharing. So 5 and 20 are sharing that node, and then 1 must be in series with 5 and 20 in parallel. So we'll write that equation out like this. This is equal to 5 parallel 20 plus 1. Okay, and 5 parallel 20 is equal to 5 times 20 divided by what? Divided by 25, which is 4. And then we know that R Thevenin is 4 plus 1, which is 5 ohms. So this inductor sees 5 ohms of resistance. Okay, and real quick, this is the shorthand trick for just 2 resistors in parallel. You could use the longhand formula, like the deal the reciprocals and things like that, but this is the short trick. So you go resistor times resistor and resistor plus resistor. That's what you do if you have 2 resistors in parallel. And yeah, it's a little short trick. Okay, so, oh, damn it. We could say that tau is equal to L over R, which is equal to L is 2, R is 5. Okay, so that's good. This is unit seconds. So we're nearly already done. Now we just gotta ask ourselves a question, what is I of infinity? Okay, well, it's just an RL circuit, right? This means that over an infinite amount of time, that all the energy will be dissipated, all the current will be dissipated into these resistors, right? There's a lot of resistance here, but there's, right? I mean, all the energy is just going to keep cycling in and out, in and out, in and out, and then eventually over amount of time, an infinite amount of time will be 0. So I of infinity is equal to 0. Okay, and that's enough information to already answer our first question. So I of t is equal to, so this is 0, this is 0. And they told us that IO is 20. So it's going to be negative 20. It's not negative, my bad. 20, so it's just 20 e to the negative t over 2 fifths, and we'll make it look nicer. This is 20 e to the negative 5 over 2 times t. Okay, so there we go. That's part 1 done. Let's do the second part. We'll do the second part in green. So what about V of t? Okay. So the voltage here, like the voltage across this resistor is the same voltage right here. We could kind of use some information about that. So there's another trick we could also use. You know that V is equal to, one second. Sorry about that, I didn't want to tell you guys the wrong formula, so I had to search it up real quick. So you know that VL is equal to I. Wait, one second. VL is equal to L di dt. Okay, so, and like I said, the voltage across this resistor is the same voltage here, right? So this tells us a good amount of information. So this is 2, and then what's di dt? So if we take this derivative, right, this is I of t. If we take I of t's derivative, it turns into di dt, right? So we need to take this derivative. So it'll be 20 times negative 5 over 2 e to the 5 over 2 t. Okay, and if we clean all this up, 2's go away, and we get negative 100 e to the negative 5 over 2 t. Okay, now this is just the resistance for VL. I mean, just the VL. But there's a little bit more we have to do, right? Okay. So we need to think about this as, let me go to V of t. V of t for this 20 ohm. Okay, my bad, actually. I was saying something slightly wrong. The voltage across this inductor, it's also the voltage right here. So it's this, we call this V1. This would be V1. So V of t is equal to V1. I mean, this is VL, this is V1. And then they're equal to that. So V1 plus VL. Sorry, I didn't say anything wrong earlier. I just said something slightly wrong. But this is true. Okay, V1, there's this voltage here and a voltage here, and they should equal out to V20. And we'll write V sub 20. So we want to find this, but we're going to use these two facts to find that. Okay. So V1 of t. Okay, V1 of t for this 1 ohm resistor, we could think about it this way. We could think about it this way, that there's the current going through this inductor is going to be the same current going through this 1 ohm, right? So then, right, we go V1 of t is I of t times R, right? Okay, and then that just, this is just 1, since it's 1 here. So it's 1 times this. So it's 20 e to the negative 5 over 2 t. Okay. So now this added with this, right? So that added with that. Let's do this in black. So V20 of t is equal to this one plus this. So 20 e to the negative 5 over 2 t plus. Now it is a plus, but there's a minus here, so I'll just write minus. Minus 100 e of the negative e to the power negative 5 over 2 t. And we see that these are like nearly the same thing, except the coefficient is slightly different in the front. So you could just do this like simple algebra, right? So it's going to be negative 80 e to the negative 5 over 2 t. So that's it. Yeah, all of that. Sorry, I watched over the recording before I uploaded this, and I maybe said a few things kind of confusing around this area. So let me just clear it all up. Okay, so we want to find V of t that corresponds to this 20 ohm resistor, right? So this here right? This here would be the equivalence to this here, right? Because this current is going into here, and this current's going into here, and this current also goes all the way down to here. Okay, so if you agree with me on those two facts, then we could use the fact that V1 plus VL is equal to V20. And that's just KCL for this little loop, right? That would just be KCL if you think about it. Okay. And if you see that V1 of t, well, we'll start off with VL. So this formula, we all know this formula, VL is equal to L di dt, right? So if you just take the time derivative of I of t right here, and then you multiply it by L, which is given, you get this answer. Okay. And then if you add that to what V1 is, and you ask yourself, what is V1? Well, V1, right, the voltage across this 1 ohm resistor, well, I of t is still flowing down this. So I of t right here, it's right here. But then we want V, and then we get to use Ohm's law, which is I times R. And R is just 1. So it's just 20 e to negative 5 over 2 t. And when we add them, we get this answer. Okay, so again, it's just kind of the idea that here's this little network right here like this. We just analyze for this 1 ohm. I mean, the voltage across this 1 ohm resistor. We analyze VL here. And that should be equal to this voltage right here, right? That's the idea, that's the concept. Consider subscribing and liking if you found this video interesting or helpful. Leave a comment. Just leave any comment, just so I could, get this video pushed up in the algorithm.